Welcome! It's Miss Skelton here, and today this video is going to help you solve quadratic equations. We're going to use square roots to do that. So if you remember last week, you focused on how to simplify square roots by looking for pairs of numbers. We're going to keep practicing that this week, and we're also going to solve quadratic equations. So you'll see all of the problems have a squared in them, an x squared. A few weeks ago we did this by factoring. We had to make the equation equal 0 and use the box. And this is a different method that's going to help us solve a different kind of quadratic equation. So I'm going to write the steps first so that you can refer back to them. And then we'll actually get into when do we use this and what do the steps look like. So step number 1 is to isolate the squared term. So we're going to cancel any other numbers in the equation so that the part that's squared is by itself. And then the reason we did square roots is because they're the opposite of squaring. Just like addition and subtraction are opposites, we are going to cancel the squared by taking the square root of both sides of the equation. And then the third and final step is that we're going to simplify the square root like we did in last week's video. So when can I use this method? Well, if you look at all of these and you think about the general standard form equation we had been using for factoring, we can use these steps. Here's an x squared, here's a b squared, x squared. All of these equations have an x squared, they have another number, but they don't have a bx in the middle. So I'm just going to write, this is what we had before, and we use this method when the x term is missing. Okay, so I just want us to do a real simple one for a second. If I say x squared equals 9, I'm asking you what number times itself makes 9. Okay, hopefully you're like, oh, that's easy. X should be 3, because 3 times 3 is 9. Well, there's also another answer. What other number times itself makes 9? Maybe you thought to yourself, oh man, if I did -3 times -3, that would also make 9. So today, all of our problems are going to have two answers because both a positive and negative version of the same number multiply to make the total. So to show that, we're going to use a symbol today. It's a plus sign on top of a minus sign, and it means positive and -3 are both the answer. So when we get to the last step and take the square root, we're always going to go ahead and put a plus or minus. Okay, let's try some of these. So number 1, we are going to get the squared part by itself. That means I need to cancel the 2 in front of x squared. If 2 is next to x squared, they're multiplying. So we're going to divide by 2 to cancel the 2 first. And now I get x squared equals 4. Now once the squared part is alone, notice here only the x was squared, not the 2. And that's why we divided by 2. Then I'm going to take the square root on both sides. Square root and square cancel out, leaving me just x equals, and the square root of 4, that's a perfect square. 4 comes from 2 times 2, but we're going to show that both positive 2 would work, because 2 times 2 is 4, and also negative 2 would work. So positive and -2 are both answers. You can either write them out separately like we did here, but the plus or minus sign saves you time. You don't have to write it twice. Okay, let's try another one. The next one says b squared plus 4 equals 12. So I'm going to cancel the plus 4 by subtracting 4 on both sides. I get b squared equals 8. And now that the squared part is by itself, I'm going to take the square root of both sides. So b equals, I'm putting plus or minus so I don't forget. Now this one, 8 is not a perfect square. So we're going to want to go to this side, take the square root of 8, and like last week, let's try to simplify that. 8 comes from 4 times 2. I can keep breaking down 4 into 2 times 2. So I have a pair of 2's that would go in front of my square root of 2, and a leftover 2 under the square root. So I don't want you to leave these as a decimal. I don't want you to type it in a calculator. I want you to leave it in simplified square root form. Okay, let's try another one. All right, number 3. We have 4x squared equals 9. Okay, so let's cancel that 4 by dividing, since it's trying to multiply by x squared. So I get x squared equals, and I know it's tempting to make this a decimal, but I don't want you to. I want you to leave it as a fraction. And now to cancel the squared, we'll take the square root on both sides. And the nice thing here is that these 9 and 4 are both perfect squares. So if I think about them separately, on the top, the square root of 9 is 3, and on the bottom, in the denominator, the square root of 4 is 2. So the answer here is positive and negative 3/2. Awesome, let's try another one. So I have x squared minus 6 equals 14. Let's cancel the minus 6 by adding 6. I get x squared equals 20. And now we're ready for our square root. I'm going to go ahead, I know I need to try to simplify this. So x equals positive and negative. Remember, you can pick any pair of numbers that multiplies to 20. I'm going to pick 4 and 5. And I know there's a pair of 2's in the 4. So I end up getting, my pair goes on the outside, 2 square roots of 5. Awesome. Okay, this is one of those videos where you may want to, after we do number 5, pause it, work ahead, then check and see if you get the same answer. Or if you just like doing the examples with me, then of course keep watching the video. Okay, 5 has extra numbers in it. So it has 4x squared and a 400 equals 0. We still need to get the x squared alone. So think about a normal equation. We would normally cancel this extra number that doesn't have a variable with it. I'm going to do that first still. I'm going to add 400 to both sides. So I get 4x squared equals 400. I don't have the x squared alone yet. I need to divide by 4 first to cancel out that 4. So x squared equals 100. And now to cancel the squared, I'm ready to take the square root of both sides. So x equals, I get my two answers, one positive, one negative, and 100 is a perfect square. So I get 10. Make sure when you do have a perfect square, and you're telling me the answer is 10, that you're not leaving the square root on it. I saw that a couple times on the skills check last week. Once you take the square root and it's a perfect square, then there's no square root symbol left. You're telling me 10 times 10 makes 100. All right, onward. Okay, so let's get x squared by itself. This one's in a different order, but that's fine. I need to cancel the positive 8 So I'm going to subtract 8, subtract 8. So 45 equals x squared. And I'm ready for my square root step. So I have x is positive and negative, and then over to the side, I'm going to take my square root of 45. Let's see, 5 times 9 makes 45. I can keep breaking down the 9 into 3 times 3, which is a pair. So I'll end up having that 3 on the outside, and then a 5 under the square root. So x is positive and negative 3 square roots of 5. Okay, let's do a few more. All right. So on the next one, we have 9n squared minus 14 equals negative 3. So I'll cancel the minus 14 by adding 14. 9n squared equals 11. Divide by 9. And you know I'm going to want you to leave it as a fraction. Okay, now I can take the square root of both sides, and I'm going to think about this fraction as 2 separate square roots. I'm going to ask myself, can I simplify the top? Can I simplify the bottom? So on the top, 11 is not a perfect square. I can't break it down. It's just 11 and 1. It's a prime number. So it's going to stay the square root of 11. But on the bottom, the square root of 9, that is a perfect square that comes from 3. So I'm going to change it to the square root of 11 over 3 because we simplified that denominator. Awesome. All right, let's do a few more. Okay, so here I'm going to subtract the 12. So I get x squared equals, well, 12 minus 12, that's just 0. Okay, so when I take the square root of 0, x is 0. And you don't have to put plus or minus here because 0 is not positive or negative. It's the absence of all value, so no sign needed. So that one only has one answer. Okay, just a few left. 10, 11, 12 get a little, just slightly trickier, but number 9 looks similar, so let's keep going with that. I'm going to subtract the 21. So I get negative 16 on the right side. I'm going to divide by 4. So I get x squared equals negative 4. Okay, I know this feels like a normal question, a normal problem that we've been doing today, but there's actually a problem here. Because if I ask you what number times itself makes negative 4, well, if you tried negative 2 times negative 2, it would make positive 4. Obviously, if you picked 2 positives, they make a positive. And you can't pick opposite signs because then it wouldn't be a number times itself. So in your calculator, if you have a graphing calculator app, I'm just going to show you what would happen. Anytime you try to take the square root of a negative, so that square root symbol is second, x squared, just as a reminder, you get an error because it's a non-real answer. In Algebra 2, you'll actually learn that imaginary numbers exist. I know it sounds like I'm making it up, but this actually has an imaginary answer, a non-real solution. So here, what I want you to say, we're not going to say x equals. We can use the no solution symbol, or we could say no real solution. And this will happen anytime we try to take the square root of a negative. So if you want to make a note, can't take the square root of a negative number. And we'll take that fun for Algebra 2. Hopefully I get to see some of you again in that class. Or you can always come back to me for help too, when you learn about imaginary numbers. Okay, the only other way you might see a problem like this is 10 through 12. You'll notice that these problems all have parentheses that are squared. So it's not just an x squared, it's this whole expression of x minus 4 squared. We are going to try to get that expression by itself. Alright, now if we were in class, I know some of you would probably ask, hey, there's a 7 outside. Should I distribute that? And the answer is no. We can't distribute it because order of operations, PEMDAS, please excuse my dear Aunt Sally, would tell us we would have to square this first. We would have to simplify by using the exponent, and then that would require us using a box, which we don't want to solve it that way. So instead, we are going to try to isolate the parentheses using the same steps from the rest of the video. So let's try it. I'm going to start with this extra number and cancel it by adding 18. So then I get 7 times x minus 4 squared equals 28. Still trying to get the parentheses alone. The 7 is next to the parentheses multiplying, so I'm going to divide by 7 on both sides so that the parentheses that are squared are alone. I can't move this 4 yet because it's stuck in the parentheses being squared. So once I have the squared term alone, this is where my square root step comes in. I get x minus 4 equals positive and negative 2. So here's where I'm using the plus or minus sign. Every time you take the square root, that's when you're using plus or minus. And then to get the x by itself at the very end, we are going to add 4 to both sides. So I'm going to go over here so that we have some space to talk about what this means. So the general way to write this is to keep the plus or minus 2 in the middle and the plus or minus 2 at the end, and to put this 4 first. So we can actually figure out the two answers. They're not going to be the same number here. We're going to have to use the plus and the minus sign. So one answer is saying that we want to do 4 plus 2, which is 6. To get the other answer, instead of using the plus, we'll follow the minus sign. 4 minus 2, which would be 2. So on a problem that has parentheses squared, there's a good chance you're going to get two different numbers and not just have one answer with a plus or minus sign. Okay, I know that's kind of a lot, so that's why we're going to do a couple more like this. All right, number 11, decide what part are we trying to get alone. We're trying to isolate the part that's being squared. So let's cancel all the numbers around it. We'll start with this extra number and we'll subtract 2 from both sides. I'm going to bring down 3 times x minus 3 squared equals 24 when I do 26 minus 2. The 3 is trying to multiply, but instead I'm going to divide by 3 on both sides. And I get 8. Now that I have the squared parentheses alone, I'm ready for the square root of both sides. So when I square root, it's canceling the squared and leaving me just x minus 3. This is where my plus or minus comes in. 8 isn't a perfect square like this last one. So let's go to the side and let's simplify simplify the square root of 8. 4 times 2, 2 times 2. So I have a pair of 2's and a leftover 2. And at the very end, we want to then make the x by itself, so I'll cancel the 3. Now I'm writing it underneath this term, but we're going to have to talk about how this is written. So x equals, this 3 and 2 do not get to combine together in this problem because they're not like terms. This 2 is 2 square roots of 2. It only could combine with other square roots of 2. So the way that we'll write this answer is put our solo number first, leave your plus or minus in the middle, and then 2 square roots of 2 at the end. I know it doesn't look like the final answer. It looks kind of like gibberish, but we've simplified the square root fully. We left the plus or minus in the middle, and we made sure x was by itself. So this one, I can't come up with these 2 answers because I didn't have a perfect square here. So on these types of problems, there's some on the guided practice that you don't have to actually submit. If you feel good about this topic, I would suggest at least trying the problems like this on the guided practice before you do your quiz or submit your worksheet for the week. Okay, final problem. X minus 1 squared. That's what we're trying to isolate. That means I need to cancel the 1/2 that's in front. So there are a couple ways to think about it. You can divide by 1/2 on both sides and do that in your calculator. Like 3 divided by, and then use a fraction, 1/2. To get 6. Sorry, you can't see that. But another way that we talked about doing this at the beginning of the year is if you think of a fraction as 1 divided by 2, just rewriting the problem, then we can cancel the divide by 2 by multiplying by 2 on both sides of the equation. So the times 2 and divide by 2 are going to cancel, and that just leaves me with 1 of the x minus 1 squared left. 3 times 2 is 6. Okay, now that I have the squared part alone, I can take the square root on both sides. X minus 1 equals plus or minus, okay, square root of 6. If you try to simplify that over to the side, well, that just comes from 2 times 3. No pairs, so it's going to stay the square root of 6. All right, let's go ahead and cancel out. I'm going to add 1 so that x is going to be by itself. And I know that 1, the positive 1 I'm adding, is going to go in front of the plus or minus sign, and the square root of 6 will stay at the end. Final answer. Awesome. So this week you do have a guided practice, so you can check your answers along the way, 1 worksheet to submit, and then a skills check as well. We are really in the home stretch, guys, so hang in there, and please make sure you're reaching out to your teacher if you have any questions. All right, I hope you found this video helpful.